now that we've learned about some sine, cosine, and tangent, and our cosecant, secant, cosecant, all our trig functions, our 6 trig functions, now let's go ahead and see how we can apply them into some triangles. So here we're going to find the missing lengths of some sides and some triangles, all right? So to do that, we need to take what we know about sine, cosine, and tangent and write some equations, all right? So when we're solving for a missing side, we want to ask ourselves which function applies. Does sine, which is opposite leg over hypotenuse, cosine, which is adjacent over hypotenuse, or tangent, which is opposite leg over adjacent. And then we're going to substitute the values we know and use our calculator to evaluate it. All right, so here we have a triangle over here, a right triangle. Now, this is only for right triangles right now. We'll get into other triangles later. And we know that we've got a right angle here, and we've got, let's go for some radians. Why not? 7 pi over 36. That's in radians now. Okay, and we know this leg over here, which is 15. And we want to find the length of both the missing sides. So let's call this x, let's call this y. Why not? So we got to ask ourselves this. How does this side relate to this angle? Well, first of all, it's a leg because it's connected to the right angle, so that makes it a leg. And second of all, it's all the way on the other side of the angle, so that is the opposite leg. Down here is the adjacent leg. It's connected to the angle we know, and this is the hypotenuse because it's opposite of the right angle. So we've kind of defined all 3 sides now. Well, let's go ahead and see if we can find x. Well, x is the adjacent, and 15, the one that we know, is the opposite. Well, we know that the tangent of b, I'm going to use angle B because that's a B down there. The tangent of this angle is defined as opposite over adjacent. And I know how big B is. We're told that B is 7 pi over 36. That's a funky pi. All right? And do we know the opposite? Well, yes, we do. The opposite is 15. And do we know the adjacent? No, we don't. It's x. So we've got the tangent of 7 pi over 36 is 15 over x. Well, we can find the tangent of 7 pi over 36 using our calculator. So let's go to our calculator and make sure it's in radian measure. And then type in tangent of 7 pi over 36. So 7 pi slash 36. And when you punch that in your calculator, you should get 0.7002075, so on and so forth. We'll round this to 4 decimal places, all right? Now we need to solve for x. Well, to solve for x here, we've got to get it out of that denominator, so we can think of this as over 1, and we can cross multiply here. That'll work. Okay. When we cross multiply, we get 0.7002. X equals 15 times 1, or basically we just multiply both sides by x. And let's divide by the 0.7002, and we get this 15 over 0.7002. Let's go ahead and figure out what that is. Erase that. 15 divided by 0.7002 gives us 21.4. All right. Let's keep some decimals of accuracy here. So we'll leave it at that. All right. So we found x there. Now, a couple little things here that happen that are going to be useful. At this situation right here, notice that this 0.7002 and the x just traded places. When we got over to here, we have x equals 15 divided by 0.7002. Well, that's because of this property of proportions that's going to be real useful to us, and that is this. If a over b equals c over d, then we can swap these two, and D over B equals C over A. All right, so we'll call that the swap property. And I'll show you here on this next one how that's going to help us, that swap property. You can swap diagonally when you have a proportion. Well, here's how that's going to help us. I want to find y now. Y is the hypotenuse, and we know the opposite. Well, that's going to be sine. The sine of angle B is opposite over hypotenuse. Always start by writing this trig equation. Well, the sine is 7 pi over 36. That's the angle, sorry. And we want to find the sine of that angle. We know the opposite, and the hypotenuse is y. Now, the sine of 7 pi over 36, that's just some funky decimal number. And I don't want to figure that out right now. I'm just going to leave it alone. So we got some weird decimal, and let's go ahead and put that over 1. So weird decimal over 1 equals 15 over y. And we got a proportion. I'm going to use this thing that we just did up here. Notice in the proportion that if we want, I can swap these two things, and the D and the A, and rewrite a new proportion, and this is also true. You can notice they have the same cross product. So let's go ahead and swap here. So I'm going to take these two, and I'm going to swap them and rewrite the proportion. So our new proportion looks like this. Y over 1 equals 15 over sine of 7 pi over 36. Now, notice I haven't gone to my calculator yet. I haven't done any decimals. So go to your calculator now and just crank this out. 15 divided by the sine of 7 pi over 36. You can do it at one time. You don't have to do a two-step process. And so if we divide that out on our calculator, we should get about 26.15. We'll round that off to 26.2. All right? And that's good because that's the hypotenuse. The hypotenuse is the largest side, and that's larger than these two here. So now we can find missing sides using trigonometric functions, sine, cosine, and tangent. If we want to go backwards now, we can find the angles. So sometimes we know the sides and we want to find the angles. To do that, we're going to go in reverse or use what we call the inverse sine function. All right? Inverse sine kind of undoes sine. All right? Another name for sine, inverse sine is called the arc sine. Okay? So this will undo sine. This will find the angle. So inverse sine is sometimes called the arc sine. It's written like this, sine to the -1 of r. It's not really an exponent there. That's just a symbol that we use for inverse. And this does not mean 1 over sine, because 1 over sine is cosecant. So when we're talking about the inverse sine, the question is, what angle has the sine of r? That's what this means right here. So we could also do this for inverse sine, inverse cosine, tangent, inverse cosecant, and all the others. So here we have a triangle, a right triangle specifically, and we want to find this angle. Well, we have two of the sides that are given to us. If we wanted to use the Pythagorean theorem, we could find this other side, but we don't want to do that. So let's identify these sides. First of all, we have this opposite one over here. That is the opposite leg. And this 12 right here, we know is the hypotenuse. All right? So we have opposite and hypotenuse. So we ask ourselves, which trig ratio is opposite and hypotenuse? Well, that is sine. So the first thing we do is exactly like we did up above. Start by writing a trig equation that is true. The sine of A is opposite over hypotenuse. That is our trig equation. That is the definition of sine, okay? And so now we ask ourselves, well, what do we know? Do we know A? No, we don't. Okay, that's theta. Maybe I'll put a theta in there. You can leave it as A, that's fine. But we do know the opposite. The opposite is 3. The hypotenuse is 12. Now, we're asking ourselves this question. What angle has the sine, in this case, of theta? So what angle has a sine of theta? That is the inverse sine. So we want to find this out, what the inverse sine of 3/12 is. And make sure that we have it in degrees. In this case is probably a good way to go. So we want to, this is approximately 14.47. We'll round it off to 14.5 degrees. Okay. Directions here on this one, by the way, were to solve the triangle. Solve the triangle means we want to find all the missing sides and the missing angles. Well, we knew we had angle B. Angle B, measure of angle B is 90. The measure of angle C is going to be the left over 90, because these two angles add up to 90, because it's a right triangle, so these two have to add up to 90. So we have 90 degrees minus 14.5. Okay, that's an ugly point there. And so that's going to be, what we got, 75.5 degrees. Okay, so there's 90, 75.5. And last but not least, we need to find this third side. And so we've got, let's call this x here. We've got x squared plus 3 squared equals 12 squared. So x squared plus 9 equals 144, and 144 minus 9 is 135. So x equals the square root of 135. And I do believe that 9 goes into 135. It's 45 times 3. So this simplifies to square root of 9 times the square root of 15, which is 3 square root of 15 for side AB. All right. So we have solved the triangle. So again, the process here is ask yourself, what sides do we know? Which one of these ratios is that? Write one of our trig equations just by the definition, fill in what you know, and use the inverse sine or cosine to find the angle. There you have it. Have fun with trigonometry.